All right, so let's take a look at the solutions to this quiz. First, we want to state the chemical formulas for both of these reactants, which we are going to perform a reaction with. So our first is copper to nitrate, and when we're looking at an ionic compound, it's really good to break down what exactly are the anion and the cation in this compound. Copper 2, this is Cu2 plus, copper 2, and nitrate is NO3 minus, a polyatomic ion that hopefully we're pretty familiar with by now. When they come together, we're going to have 1 copper and 2 nitrates so that the charge is equivalent, and it's going to be aqueous as it contains that nitrate ion. Sodium hydroxide, we have Na plus, OH minus, sodium and hydroxide, and they'll combine in a 1-to-1 ratio, again being aqueous as we have a sodium group 1 metal. So in part B, we're saying, well, we have solutions of these two ionic compounds that are combined, and the mixed solution becomes cloudy, and we conclude a reaction has occurred. Now, this is a very important step because it helps us understand that this is not a no reaction reaction. We do have something that's forming, and therefore we definitely should expect that there is a reaction that's going to occur here. So what type of reaction, and then what are the products and reactants that are in this reaction? So we have our two reactants and we have our states for those as well. So that part is done. And when we bring these two ionic soluble compounds together, we're going to have a double displacement reaction, right? Both of these are aqueous. And if we form something, this is going to be a double displacement or a precipitation reaction. What are the products here? Well, we want to switch our ions around, and therefore we have copper nitrate and sodium hydroxide, which is going to form copper hydroxide and sodium nitrate. Sodium nitrate with sodium and nitrate is definitely going to be soluble, but the copper hydroxide is going to be our precipitate, and that one is going to be insoluble once we check our table. But honestly, with the information that's given here, if we know that there's a precipitate being formed and we know that it can't be sodium nitrate, we may not really need to check the reaction table here as we already have a result that we're looking at. Balancing the chemical reaction, we need 2 hydroxides and 2 of the sodium nitrates. The sodium hydroxide and the sodium nitrate both need a 2, and now we have a balanced chemical reaction. Okay, so now that we have the balanced chemical reaction, what is the net ionic reaction? And let's remember our procedure here. We begin with our balanced chemical reaction. We've already solved for this. And now we want to take a total ionic reaction, which is no more than taking all the aqueous ionic compounds and showing them as split up into their ions. And I do want to pay attention to the notation here where I didn't put an aqueous state on any of the substituted ions where I actually show them with their charge. And the reason for this is because we don't just have positively or negatively charged stuff that's in the solid, liquid, or gaseous state. They're only sort of viewed alone in this way because they're in an aqueous solution where the negative charge is out there as well. And so overall, they do cancel each other out, but it's just to say that they can't really be in any other state other than aqueous unless we're dealing with some rather novel materials, which in this particular course, we won't be. So when we have them shown as dissociated, it really is understood that we're dealing with aqueous solution where that's where those ions are living, and I don't think it's necessary to put the aqueous subscript on those. Now we want to think, are there any spectator ions? Because these are the ones that we don't want to show up in our net ionic reaction, and I see that we have sodium and nitrate that are both the exact same on both sides, and we write our net ionic without those, and we have copper and 2 hydroxides forming copper 2 hydroxide. Now our final question is saying, well, what about some stoichiometry here? If we start off with a quarter liter, 0.250 liters of 0.50 molar copper 2 nitrate in combination with excess sodium hydroxide, so not a limiting reactant problem, all we need to deal with is the amount of copper nitrate. We want the mass of product that's formed. And so again, we always want to start with what we know, which in this case is the 0.250 liters of solution. From this in the molarity, we can get the moles of copper 2 nitrate, then we can get the moles of the product and convert that to the mass of the product. And this is the layout of how we would do that. And we get 12.2 grams of copper 2 hydroxide that are formed. Now, keep in mind that while this is a little bit different than our grams to moles to moles to grams calculation that we've done previously, this beginning part is the only thing that's different, and this is how we get to moles of our copper 2 nitrate reactant by taking the volume and converting it to the moles by using the molarity. And once we do that, we're in terms of moles, we can get moles of anything else in the reaction. And then if we get the copper hydroxide precipitate, we can find the mass of that precipitate by using its molar mass, and we arrive at 12.2 grams.